A very good morning to one and all present here. It's a wonderful day, and I feel privileged to extend my warm welcome to our beloved Professor Dr. Jitendra Mungara sir, Principal of NCET, and Professor Dr. Mohan Kumar sir, Dean of Quality Assurance Department, NCET, and our resource person and Speaker of the Day, Dr. P. Mangayarkarasi, Professor, Department of ECE, Saveetha Engineering College, Chennai. I would also like to welcome our HODs, faculty members, and all participants. Today we have gathered here for a webinar on pattern recognition and artificial intelligence organized by Department of IQAC and Department of CSE and ISE. It gives me an immense pleasure to start this auspicious occasion by heartily welcoming our speaker of the day, Dr. P. Mangayarkarasi, who is a highly motivated professional with excellent academic track record. She is a professor at Saveetha Engineering College, Chennai, Tamil Nadu, India. She has more than 2 decades of working experience in academia, research, and consulting. She is also a planning engineer at Aero Fashion Fasteners. She has published more than 6 books. She has also published 14 research papers in international journals and 7 research papers in an international conference. She is also a journal editor for International Scientific Journal of Contemporary Research in Engineering Science and Management, and reviewer for various international journals. She has taken up more than 6 research-funded projects, and she is also a life member of Indian Society for Technical Education and a senior member of Institute of Electrical and Electronics Engineering, that is IEEE. She is a reviewer and editorial board member for various reputed international and national journals, conferences, and symposiums. Her current research interest includes wireless networks, wireless communication, and optical communication. It is my privilege to introduce our speaker, Dr. P. Mangayarkarasi, to our esteemed audience. Welcome, ma'am.
Thank you, sir. Thank you, sir.
Now, without further ado, we'll turn the time over to introducing our Nagarjuna College of Engineering and Technology to our speaker and participants.
Founded in 1995 by Sri J.V. Rangaraju, Nagarjuna Group of Institutions has emerged as an epitome of educational excellence and has stood the test of time ever since. We stand strong on the pillars of academic professionalism and educational distinction. Our reputation lies in our unique offerings to students via our education. With more than 10,000 students nurtured by 1,000 plus exceptional faculty. At Nagarjuna, we focus not just on academic development, but also on a student's overall growth. Our lush green 100-acre campus offers an environment conducive to learning. Our sterling infrastructure is equipped with modern amenities, well-equipped labs, smart classrooms, Wi-Fi enabled campus, indoor and outdoor sports center, gymnasiums, cafeteria, hostels. At Nagarjuna, we always aim to create experiences with our learning process. Many activities, events, seminars, workshops, and fests are organized on campus to enhance the overall development of the students. NCET is our college for engineering and technology. It was established in 2001 and it has been approved by AICTE with NBA accredited courses. Accreditation with A grade by NAC and ISO certified for its Green Initiative. It is one of the most prestigious autonomous institutions in the state of Karnataka. At NCET, we emphasize on practical learning as well as academic theories. We follow a student-centered pedagogy and have a project-based learning system to make students future-ready. We are associated with reputed organizations that offer excellent employment and internship opportunities to our students. The international internship opportunity provided for the students helps them to widen their technological horizon. We are associated with some of the best technical universities in the world. Our highly disciplined placement training center prepares students right from the first year on various aspects of the interview.
Thank you, everyone. It is my privilege to introduce our speaker, Dr. P. Mangayarkarasi, to our esteemed audience. Welcome, ma'am. Now,
Thank you, sir. Thank you, sir.
now I would like to request our speaker to take over the session. Over to you, ma'am.
Thank you very much, Abraham, sir.
Thank you,
Good
ma'am.
morning, all of you. I'll present my screen, sir.
Yes, ma'am. Yes, ma'am. Ma'am, I think the fan noise is there.
Okay, sir. Just a minute. Once again, sir. Now is it okay, sir?
Yes, ma'am. Yes, ma'am.
Okay. Good morning, all of you. So before starting, I would like to thank Professor Dr. Jitendra, Principal, Nagarjuna College of Engineering and Technology, Professor Dr. Mohan Kumar, sir, Dean, and then I would like to thank Dr. Dinesha, sir, head of the department CAC, for giving me this wonderful opportunity to deliver and share my knowledge regarding this topic, pattern recognition. I also thank Mr. Abraham and Mr. Srikanth for coordinating this and for delivering all the information that is providing all the link and everything to me on time. Thank you very much. Let me start my session. Hope my voice is audible. Sir?
Yeah,
Yes,
ma'am.
ma'am.
You are welcome. So go ahead, madam. Your voice and
Yes,
P1
ma'am.
PPT slide is very clear. Go ahead.
Thank you very much, sir. Thank you very much, sir.
Yeah.
Abraham, sir, my network is not stable. I'm in PPT mode or I'm in slideshow mode. If there is any fault regarding my network issue, can you call me?
Yeah,
So
ma'am,
that I can
sure.
check my network because this happens repeatedly even if I take my online class.
Okay, ma'am.
I may not know that whether I'm in network or not because I'm in the slideshow.
Yeah, if it is there is any issue, I'll call you on WhatsApp.
You call me immediately so that I'll check my network connectivity, sir.
Okay, okay, ma'am.
So pattern recognition. Hope you might be familiar. For the past 3 to 4 years, we might be repeatedly using these topics, pattern recognition. Anybody is aware of this topic now? What do you mean by pattern recognition? This is a general term. It's a common word, pattern recognition. So why do we give that much of importance to this pattern recognition? Anybody can share your ideas about this pattern recognition? If not, no problem. I'll carry on. So what is a pattern? Pattern is a common word. See, I'll tell you why are we going for this type of topic, pattern recognition. See here. So is the slide, can you follow the slide? Is the slide understandable? Hope you might be familiar with this topic, artificial intelligence. This is a complete technology landscape of artificial intelligence. Okay. Well, most of you might have heard this term artificial intelligence, and this is ruling the world now. Artificial intelligence is ruling the world now. Do you agree with me? Do you agree with me? So this is the current trend. Okay, but all in the fields or they are interrelated. So they rely upon this artificial intelligence. So intelligence is nothing but learning and solving the problems in a wise manner. This is a general intelligence that is done by means of a human brain. Artificial intelligence. The same thing is done by means of smart machines. All the tasks of your human brain will be done by means of smart machines. That is your artificial intelligence. Just because we involve these machines to do all the functions of your human brain, so we go in for all these topics. We need all these research areas for this artificial intelligence. One among this area is pattern recognition. One among this area which is related to that of your artificial intelligence is pattern recognition. Because pattern recognition, this is simple. For a human brain, this is a simple word. So we can recognize whatever the pattern we see, we can recognize. Pattern is nothing but a repeated way of representing an object. Okay, in a regular manner. Okay, in a formal manner, in a regular manner, we can represent an object, a shape, a repeated occurrence. Okay, a repeated way of representation of your object. That is called as a pattern. This is a common word. As far as the human brain is concerned, so we can, whatever the pattern, we can easily identify the pattern. We can recognize the pattern, to which pattern it belongs to which color it belongs to which shape it belongs to. Everything we can easily recognize. But as far as your human brain is concerned, this is a very important topic. Because all these should be recognized by means of a human brain. It has to recognize what type of pattern it is, what type of color it is, what type of shape it is. Everything has to be done by means of human brain. Okay, so that is a very complicated task. So we need to learn a lot. We have to give a lots and lots of input to the human brain. That is a smart machine, computer. So that it has to recognize, it has to act in a similar way as that of human brain. Okay, so for that, pattern recognition is said to be a very important topic as far as your artificial intelligence is concerned. So today, we'll discuss this because it is an ocean. Okay, it is an ocean. So just I'll give you overall idea of pattern recognition. Because we have only 1 hour of time within this 1 hour. So I'll see how prepared nearly 120 slides. So I'll be rushing up with the first 17 slides I'll be rushing up. I've given a lot of images in my PPT. Okay. Oh, definitely you'll find this lecture in an interesting manner. Okay, so these are the topics which I am going to discuss about that. That is, I am going to give you an introduction about the topic, so which I gave you, I think. Then pattern, about the pattern, what is a pattern, and how the patterns are recognized by means of your generally how the patterns, how we will recognize a pattern. And we have, as far as this artificial intelligence is concerned, what are the various pattern recognition model. So I will give you one example how this pattern is recognized, and then what are the various approaches. Pattern recognition approaches, and finally I'll end up with the introduction to artificial intelligence. Okay, now this we have seen. Why are we going for this pattern recognition? Okay, so we want the we want the mission to recognize the patterns and act accordingly. Okay, so for that we need the pattern recognition. Can you tell me an example, really an example of pattern recognition? Anybody? Okay. So, see, in day-to-day life, when you wake up, the first thing nowadays is students, the teenagers, what you will do. First, when you wake up, immediately you will look into your mobile phones. So your mobile phones, you will be locking your mobile phones with a code, with a PIN number, or with a pattern, or with a face recognition. So this is the one of the main applications of your pattern recognition. Okay, so you'll be drawing a pattern. How that pattern will be recognized by means of your system, your mobile device. Okay, that here the artificial intelligence plays a major role. How your device recognize your pattern? Okay, so your face will be recognized. So the advanced mobile phones having the face recognition system. Okay, it will capture your face and you'll be storing your face in your database so that it will recognize. Okay, so this face recognition, everything comes under this artificial intelligence and pattern recognition. The pattern will be recognized by means of your mission, your device, your mobile device. This is one of the main applications of your pattern recognition. So likewise, day-to-day life, we can now list out lots and lots of applications of your pattern recognition, because as I said now, this pattern recognition is ruling the world now. Okay, so this pattern recognition is a branch of artificial intelligence. Okay, and then humans, see, as I said, humans can recognize the faces without worrying about the wearing illumination, but it is a complex task when it is going to be by means of missions. Okay, so we're going for this pattern recognition. So we have to formulate various approaches, models, etc. for missions to recognize these patterns artificially. So what is pattern recognition? So this Judah Hart is a famous person. He has written a lot of books based on this pattern recognition. The assignment of physical object or event to one of the several specified categories. So what's a pattern? Pattern is nothing but an object, a process, or event. So we can classify the pattern into different classes, and according to the classes we can segregate. Okay, and the classes can be done by means of a classifier. Okay, a class is nothing but a set or group of patterns which share the common attribute. So attributes are nothing but attributes, entities, or nothing but features. When they have the common features, they come under a particular class. Okay. So we have a classifier. So I think I can go with this. So we have a classifier which performs such tasks. Okay. See, the example parts I will concentrate more. The theory part I'll rush on. Okay. So example part, because example parts you will find more interesting than that of your theory part. This is as usual. Even in the case of your academic theory classes, when we go with an example, a real-time example, you will find more interesting, the topic to be more interesting. So I'll be scrolling this, what is this, these slides. Pattern recognition. So pattern recognition is nothing but pattern plus recognition. We're going to, that is what your device, your mission is going to recognize the objects. Okay, so recognition, cognition is cognitive skill. Okay, cognition is nothing but cognitive skill. It is going to identify, it is going to analyze. Okay, and then it has to provide the reasoning, yeah? Cognitive skills of the brain. So that will be done by means of your mission. Recognition. Okay, to know, come to know the act or the process of the entity. Okay, that is the cognitive skill. Okay, so in the case of the main goal, what is the main goal of this pattern recognition? So it has to make decisions. Once it observes the pattern, it has to make this decision. If it is going to be visual example, so it is going to observe the there is a image of a person. So it is going to decide whether the person is happy, is in a sad mood. Okay, whether the speaker during the speech process, whether the speaker, if an image of speaker is given to the mission, from that image, the mission has to identify whether the speaker says yes or no. Physical example, we have so many physical examples, whether the given thing is an atom or molecule. So likewise, so main recognition, that is the main goal of the pattern, is to make decisions. Okay, now coming to a pattern. So as I said, pattern is nothing but a repeated occurrence. It is a design, repeated occurrence, the repeated occurrence of an object or a design. Okay, in a regular manner, in a similar manner, it has to happen. So examples we have fingerprint, image, handwritten word, human face. Okay, these are some of the examples of a pattern. So here I have given so many examples of patterns. See here. So this is a fingerprint. These are the shapes. Okay, see here. This is a barcode, and this is a atomic representation here. Chemical patterns. So I'll scroll these slides. Example of patterns. See, crystal patterns, atomic or whether they are atomic or molecular. Then comes, we have constellation patterns. You might have studied about the constellations. Okay, this is the constellation patterns. So which is represented by means of a two-dimensional planar graphs. Then we have biological patterns. See here, we have the roots of the tree. Different roots of the tree can be represented by means of the biological patterns here. Okay. And then now, a representation of landmarks. See here, the landmarks can be represented by means of the biological pattern. See, you can see the pattern in the form of banga. Okay, so we can represent the landmarks are identified by means of these type of biological patterns. Then we have variation. This is a human representation here. So the expression, a human expression, that is when there is a geometrical deformation in the face, and then that will be identified as it will be recognized by means of your mission that the human is happy or sad based on the expression, based on the geometric deformation, based on the light illumination, and it's a photometric deformation, and based on the transformation. Okay, three-dimensional transformations, and then noise and occlusions. Based on these, we can say that is the human, that is the mission has to say whether the person is happy or sad. Okay, so all these things can be done by means of your patterns. So these are the examples of in the case of your human. Now coming to the musical patterns. This is a Ravel symphony pattern here. Musical patterns. So this is a pattern of a brain activity. Okay, so from this, there is the brain behavior. So this type, the first image shows you the behavior of the brain in a that is in one type of mood, whether it can be a happy mood or a sad mood, or whether you're when you're performing a hectic activity. In that case, how the brain looks. These are the patterns of the brain under different activities. Okay, different patterns of your brain. Next is, this is the texture patterns, the normal texture patterns, and these patterns are generated by means of stochastic process. Then comes, this is a general magical patterns. You might have seen this magical patterns. Then comes this, the patterns in the case of your financial series, in the case of trading now, these patterns are used. See, this is also the pattern, trade chart patterns. And this is a medical. See, actually, this pattern recognition, artificial intelligence plays a major role in the case of your medical field. Okay, so here, this is a pattern. This is all the scanning and see radiology. It is mainly used in the case of your radiology. Okay, X-ray, scanning, everything is based on this one type of recognition here. So this is one among the pattern which is used in the case of a medical diagnosis. This is orthopedic. Then optical, OCR, optical character recognition. See, so now whenever you go in for a different site, whenever you go in for some secure sites, you'll be asked for capture codes. Okay, when you type, it has to recognize. That is done by means of pattern recognition. That is your optical character recognition is used there. Capture codes are based on this one. This is graphic arts. Human genomes. In the case of from medical field. Then we have acoustic signal, sound signal, representation of your sound signal. So frequency versus time here. Acoustic signal representation. Based on this, we can determine the decibels, sound in dBs. Cloud patterns, the pattern of a sky. So how the clouds in the sky looks like. So these are some of the examples of the patterns which we have seen. So just to have an idea of different, so which means that your pattern recognition so plays a wide role in all the fields. So we have seen almost all the fields. Okay. Now methodology. So methodology is that first is a pattern will be observed, and then segmentation will be done here. Segmentation or the will be after observation. By means of segmentation, we have to find out the relationship between the various patterns, and then we have to study the relationship between the patterns and the situations which is happening around the patterns. Okay, and then with this relationship about the patterns and situations, we come to know about what is the event which is taking place there, and then we'll be studying about the events and we'll be predicting the future of the events. So this is the workflow. The methodology is first we observe the patterns, observation of patterns, and we have to apply the relationship. What is the relationship between these patterns? And then patterns and its situations, how these patterns are arrived in, at what situation these patterns are arrived. And then with that, the system will come to a conclusion that events which is taking place in that around that particular pattern. And then again, we have to study about the events and the law, which is the law which is behind that event. And then from that, we have to predict the future. So we, in the sense, the mission, it has to predict the future. Okay. Next slide. Okay. So this is a process here. Pattern recognition. This is a process of your pattern recognition. First, perseverance. Okay. Then process. Then prediction. First, it has to sense, perceive, observe the environment, observe the image. Okay. And then process the image. And then finally predict. Okay, this is the perceive, process, and prediction is a workflow, is a flow for the mission to recognize this pattern. Okay. See, this is the normal law. So we have 4 steps. First is data acquisition and reprocessing. First, we are going to from this image, we are going to identify that this is the image of a particular person. Okay, first data has to be acquired and pre-processed. We have to pre-process the data, and then this data will be represented in the form of pixels, and then from that features will be extracted from the image, and then we have to make the decision whether this data belongs to this particular person, whether this image belongs to this particular person. Okay. So this is as usual. Once again, I have given this in flowchart. That is, here we'll be giving the input. For a given input, first we have to sense, observe the input. That is, sensing is done there, and in segmentation we have to segregate that. Okay, then we have to extract the features of that input, and then we have to go in for the classifier, which classifies this. Classification is done for the input, and then post processing. Finally, a decision is taken. See, for this, I'll go with an example. So classification is done by means of a pattern class. See, classifier, where pattern class is a set of patterns sharing a common attributes. So when we have the images or objects which have the common attributes, that comes under a particular class. Okay. So now I'll give you one example. So before that, we'll go for the applications. So these are some of the applications. As said, the main application of your pattern recognition and artificial intelligence is computer-aided diagnostic. In all the diagnostics, we go in for this type of pattern recognition. And then our common applications is that it is used in all engineering and technological studies. In the case of industry, healthcare, as I said, healthcare and military applications also. So this is your computer-aided design applications in computer-aided design. Then character recognition, as I said, optical character recognition. See, number plate recognition. So number plates of a vehicle can be recognized, and then captchas for security purpose. Everything can be. So we don't have any secure site without any captchas. Now, okay, so everything is based on this. What is it? Pattern recognition. Text characterization. This is also some of the applications. Speech recognition. So how your speech is recognized in the form of your electrical signals here. It is converted to electrical signals and how it is recognized by means of a measure. Okay. Fingerprint. So now we have all this biometric system in all the institutes as well as all the corporates, and everywhere we have this biometrics. Okay, which means that this plays a major role. Okay, fingerprint recognition is done by means of this pattern recognition process. Then signature. We have this signature recognition also. Now we have digital signature. In all the cases, we have a digital signature, and that is what is it? Security checking is done there. Whether it is a false signature or it is a original one, that is done by means of your pattern recognition. Then face detection. So this you might be familiar with this face detection. So most of you, when we go in for this final year projects, most of you will be doing this type of face recognition projects only. Attendance monitoring, this face recognition. I think I'm right. So location of the people, faces in the image, locations of the people's faces in the image. Okay. So face detection. So in medical diagnostic purposes. Okay. So these are some of the ones again, whatever we have dealt with, I have shown in points. These are some of the applications of pattern recognition. Once again, these are the applications. The same applications I've given here. Now, we will see this example. As I said, and we there is storing the slides of this general concepts. Now we'll move on to this. We'll discuss this application now. So consider we have see here. I'll go with the next slide. See, consider we have two types of fishes: salmon fish and sea bass. Okay, so we are going to see. Consider in a conveyor we have a lot of salmon fishes and sea bass fishes. Now we have to sort out the salmon fishes separately and sea bass separately. Okay, in a conveyor we have both the salmon and sea bass fishes. Okay, now two classes of fishes. We have to separate this salmon fish separately and sea bass separately. Classification of done here. A classification of these two fishes is done. So how we are going to do this? See, the difference between these three fishes is nothing but, see, the length of the salmon fish. See, actually we have to take several attributes. See here. First, we have to extract the features. First, we'll be taking image sensing. We'll be sensing the fish. Then we'll be segmenting that. And then we'll be taking, segmentation is done, or we'll be perceiving this image based on some features. Feature extraction. Length of the fish, lightness of the fish, width, number of shape of the fins, position of the mouth. So these are, as an example, I have given 5 attributes. We have a lot of attributes for segregating or sorting out. See, first, in this example also, I have taken only first two examples, and then I will proceed with the third one. First 2 attributes, and then I will proceed with the third one. Okay. See, when we compare these two fishes, the length of the salmon fish will be, salmon fish will be more lengthier than that of your sea bass fish. So this is one attribute, one feature of your salmon fish. The second is, see, when we go in for lighting, when we go in for lighting, see, your sea bass fish will be comparatively darker than that of your salmon. Okay, so this will be lighter, this will be somewhat darker. So these are the 2 main features which I am going to take into consideration in order to segregate these salmon and sea bass fish. Now coming to this, so these are the common attributes. These are the general attributes we can take. But first I am going to take into consideration these 2 alone, length and lightness. Can you follow? Length and lightness alone I am going to take into consideration. So with this length and lightness, so first I am going to pre-process. Using the segmentation operation, I am going to isolate the fishes from one another, and then I am going to make use of these features. Okay, the features are passed on to the classifier, and classification is done now. Based upon the length of the fish, first we are going to take. First feature I am going to take. So 2 features, as I said, 2 features we can take. I am going to take. First feature, length alone I am going to take now. So I am going to take the length. I have passed on the length of the fishes to the classifier. I am going to classify your fishes based on the length. So select the length of the fish as possible feature for discrimination. I will discriminate based on the length. Now, when I am discriminating the fishes based on the length, see, this is the output which I got. See, the first one is a salmon fish, second is a sea bass fish. See here, see this dark line, that is a black line shows you the salmon fishes, and this red waveform shows you the sea bass, red graph shows you the sea bass fish. See, now, in this salmon category, we have the sea bass also. See here, this is actually salmon. So it does classify the salmon, but we have some more sea bass here. Similarly, in the sea bass, we have some more salmon here. This should not happen. See, we are sorting out, we are discriminating these two fishes. One is we have only we should have only salmon fishes and only sea bass. That should not be mixing of both. The main process is to segregate that into salmon and sea bass. So we should not have sea bass in salmon, and we should not have salmon in sea bass. Okay, so the length. So we have taken only the first attribute, first feature alone. That is only the length alone we have taken. Here with this length is a very poor feature. So with this length alone, I cannot discriminate these two fishes. So I am taking the second. The second criteria is lightness. So I am taking this lightness into account. So upon incorporating the lightness, so with this length alone, I cannot sort out the salmon fishes and sea bass fishes separately. So I am going to select the second feature, which is nothing but lightness. Lightness means, see here with this your sea bass fish is somewhat darker when compared with that of your salmon fish. So by incorporating that feature, what happens? See here, we have segregated the salmon fish separately and sea bass separately. So there is nearly 80% of this is done here. But still we have sea bass fish and salmon, and we have salmon and sea bass. See here, we have salmon and sea bass. We have the sea bass. Sea bass is here red. That is representation in red. We have the sea bass and salmon. We have salmon and sea bass. Next is we move on to boundary conditions. So still we couldn't find out. We couldn't perfectly segregate the salmon and sea bass. So we go on to this boundary condition. So for this boundary condition, we have to take into cost into account. See, the cost of salmon fish is said to be higher than that of your sea bass. Okay, so which means that salmon is costlier than sea bass. So when we go in for the costlier fish, we don't want this cheap fish to be mixed in costlier fish. That is, we don't want sea bass to be mixed in the cans of salmon. Customers do not want, because sea bass is said to be less cheap than that of salmon. Okay, so there should not be mixing up of sea bass and salmon. But we can have salmon and sea bass. Hope you understand. Sea bass is a little cheap. We can have the costlier fish in the case of your cheap fish. Okay, we can have salmon in the container of sea bass, but we don't want sea bass in salmon. Okay, so customer do not want sea bass in their cans of salmon. So we are going to make a decision boundary, threshold decision boundary, and cost relationship. The third thing is we are going to incorporate this. Okay, see here this fish. Fish can be segregated by means of different attributes. Here we are going to take lightness and width. Okay, first we have taken length. Length is with the length we cannot determine whether this belongs, we cannot segregate perfectly. So we have taken lightness and width. So if you want to add attributes, we can add attributes, comma x3, comma x4, etc. Okay. Now decision. We go in for the decision boundary. So first we have different decision boundaries. Okay, so with the first boundary, see, can you observe this? See, I'll show you. So same diagram I've given at the back. See, this is one decision boundary, the second one, the third one. See here, this is the first decision boundary. See, can you observe? This is a salmon fish, this is a sea bass fish. See, we have a number of sea bass. These red dots. We have a number of red dots here in this black dots. So we have a number of sea bass in salmon. As I said, we do not want sea bass in salmon. We can have salmon in sea bass because this is a cheap fish. Salmon is a costly fish. So this condition, we need not bother about this condition, because the customer will not will be happy if they have salmon fish in CBAS. Okay, so in that case, we do not worry about this condition, but here we should not have the CBAS in the case of your salmon. So here we have a lot of CBAS in the case of salmon. So this decision boundary cannot be accepted. Okay, next we move on to another decision boundary. See here, this is another decision boundary. Okay, so this is another decision boundary where, see here, with this decision boundary, we have a number of it is perfectly separated. The salmon fish and sea bass fish. See here, we don't have any sea bass fishes in the salmon group, and we don't have any salmon fish in the sea bass group. Okay, so in that case, this is said to be a perfect boundary threshold condition. Okay, but this boundary condition is not used in the case of your segregation due to certain drawbacks. Okay, so we move on to another classification. Sorry, another boundary. So here we go on to another boundary. In this boundary, we have a limited number of sea bass fishes in the case of your salmon. Okay, so upon considering the three boundary conditions, this boundary condition is taken into consideration for segregating your salmon and sea bass. We have only two sea bass fishes, three sea bass fishes in the case of your salmon group. Okay, we have so many salmon in sea bass group, but this can be ignored because your customer will not find if they have salmon in sea bass. Okay, but when we have sea bass and salmon, this will become a big issue. So this boundary condition is taken into consideration for segregating. So likewise, so this is also, see here, this is a complete pattern recognition system where we will be giving the input. Okay, the input is nothing but both the fishes, salmon and sea bass fishes. It will sense the fishes and it will segment the fishes and it will extract the features and it will do the classification. Okay, classification is done by adding the missing features and adjustments and then post-processing. Post-processing, even by means of classification, if they are unable to segregate the fishes, means post-processing. Here, in the case of your post-processing, the cost is added. That is said to be post-processing. See here, the cost is added to the processing of your fishes and then the decision is taken. Even then, see, even after post-processing, the decision is not taken. But once again, the cycle is repeated here. Can you see the down arrow? This cycle is repeated until the proper decision is taken. This is a complete process of your pattern recognition system. So this is actually, I think, hope you might have understood this example. Example of salmon, separating of your salmon and sea bass in a conveyor. So as I said, we have the three main approaches of your pattern recognition. One is statistical model, syntactic model, and neural network model. The statistical model is nothing but fully mathematical model. So the pattern recognition can be done by means of your three basic approaches: statistical, syntactic, neural network model. So this is purely based on statistics from the name itself. Statistics and probabilities here, which is nothing but your mathematical, purely mathematical and probability model. Okay, syntactic model. Syntactic is a logical model. Okay, algorithms. This is based upon the formal grammar structures, automata, strings. So it is based on the logical model. Syntactic is nothing but syntax, based on syntax, logical model. Okay, the final is the neural network model. Neural network model is based upon artificial neural networks. Okay, so the machine will be able to learn and resolve the complex problems in this case because we make use of artificial neural networks in the case of your pattern recognition. So these are the basic model. Sorry, these are the complete model of your, these are basic models which completes that is a pattern recognition can be done by means of three models. And apart from this, we have one more model which is nothing but your template matching model. So we'll be having a database, a complete database of the information will be stored in your system. And whatever the pattern your your machine recognizes, it matches with the database. Okay, so when it matches, then it will be taken into consideration. That is a template matching model. Okay, so the template matching model, it is a common model which we will be using in all the system. So that I haven't represented this template matching model here. And these are the common models. These are the new models. That is a statistical, syntactic, and neural network model. So see here, I'll be just because this statistical model will be quite a little bit boring for you because it is purely related with statistics and probabilities, fully mathematical model. So I'll give you some examples in the case of syntactic model. Hope you will find very interesting. Okay, syntactic model. So I'll go with the statistical model also. So your that is in the case of your statistical model, your image will be represented by means of dimensions, in the form of dimensions. Okay, and then we make use of this probability theorems here. See here, I'll show you. Here we'll be going in for this decision rule, Bayes decision rule, Gaussian, that is multivariate Gaussian, and then we make use of this parser windows here. Okay, so in the case of a non-parametric method, we go in for the parser windows, we go in for a maximum likelihood decision estimation, etc. So these are all the various rules which we use in the case of your statistical pattern recognition. So I'll show you the flowchart here. See here, statistical pattern recognition. So here, in the case of your statistical pattern recognition, known model, unknown model. Here, in the case of your known model, we go in for this Bayes decision theory. And unknown model means we have two types of learning. Learning can be either a supervised learning or unsupervised learning. I will tell you what we mean by supervised and unsupervised learning. Again, in the case of your supervised, we have parametric and non-parametric. Again, unsupervised, parametric and non-parametric. So in this Bayes decision rule, here we have the optimal rules, plug-in rules, density estimation. Everything is density-based approach. Whereas here, this non-parametric is going to be a decision-based approach. So we make use of, as I say, Bayes decision rule, maximum likelihood, that is a theorem, and then we make use of K&N approaches, etc. in the case of your statistical pattern recognition. So we'll go for mode, it will be supervised and unsupervised learning. So we have two main categories under the statistical. See here we have supervised learning. See from the name itself, supervised. So learning of a mission will learn in the presence of the supervisor. Okay. Unsupervised means without any supervision, the mission will identify the object. See here, in this under supervised learning, see we have a set of triangles. This is a training set. We have circles and triangles and two different colors, yellow and blue. So first it will classify. That is, we'll be giving the shape. If this is of this shape, means this is a triangle. If the same shape is round, then it is a circle. And we'll be storing some colors also based on that. That is, so we'll give all these inputs to the mission. That is a supervised learning. Okay, so it will classify whether it's a triangle or it's a circle. Based on this information given to the mission, it will identify that it's a triangle or it's a circle, and then it will identify the color also. Finally, it will segregate this into blue objects and yellow objects. Okay. So here, under the supervision, it will learn. The supervision will learn about the shape, color, etc. Now, unsupervised learning. See, in the case of your unsupervised learning, we have the unlabeled training set. We have the combination of all these two colors with these two shapes. So now, in this case, the mission itself will identify based on the similarity measures. Okay, there is no any supervision for the mission in this case. Okay, it is unsupervised learning. Based on the similarity measures, here clustering will be done here. Okay, the mission itself will do this clustering. Okay, and based on the similarity measures, it will identify whether it is a triangle or it is a circle, and based on this based on this color similarities, it will identify whether it's a blue color or whether it's a yellow color. Okay, everything will be done by means of the mission without any supervision. That is called as unsupervised learning. So we come across these two types of learning in the case of your statistical approach. Now coming to the syntactic approach. Syntactic approach is nothing but same. As I told you, it is a syntax form. Okay, so here we're going for grammars, we're going for strings. Okay, so here that is nothing but Rama was a very good king. If this is going to be the example sentence, we'll be decomposing this sentences into sub-patterns. Rama is a noun. Okay, likewise, we'll be decomposing the pattern into sub-patterns, and these sub-patterns are called as primitives. Okay, so which means that here this syntactic approach is a method which consists of parsing the pattern. So simply decomposing the pattern using the syntax rule. We'll be decomposing the pattern into using the syntax rule. Okay. So here we make use of the formal grammars, strings, graphs, okay, tree-based approach, etc. There are various approaches of this syntactic pattern recognition. So I'll give you the examples. See here, this is the difference. Now you can observe the difference between the statistical and structural. Structural is nothing but the syntactic pattern recognition. Okay, can you follow? So statistical. See here, now we have got two images. One is a square and another is a another is a triangle. So in the case of your statistical, see this will be represented by means of here number of segments in the square is will be 4. Number of segments is 4. We have 4 segments. Number of horizontal segments. We have 2 horizontal segments. Number of vertical segments. We have 2 vertical segments. And number of diagonal segments is 0. We don't have any diagonal segment. This is the statistical representation of an image of the shape square. Okay. Now structural. The same image is represented in terms of your structure form. That is your syntactic form. So we have the horizontal line that is shown by means of horizontal, followed by 2 vertical lines. See here, this is a tree representation structure. We have 2 vertical lines. Then this again ends up, these 2 vertical lines ends up with the horizontal line. This is the structural representation. Now we have a triangle here, the same triangle. Here we have 3 segments, number of segments. This is statistical representation. We have got a triangle here, number of segments is will be 3. Number of horizontal segment, we have 1 horizontal segment. Number of vertical segments. See, we don't have any vertical segments, so that is a B0. We have 2 diagonal segments. So we have 2 diagonal segments. So this is a structural representation of this one. So we have 2 diagonals. See here, we have 2 diagonal segments. These 2 diagonal segments ends up with the horizontal segment. So now I hope you will come to a conclusion that this so this is the statistical representation, this is the structural representation. I mean, I've understood the concept. Okay, now we'll go on to examples of your structural syntactic, that is a structural representation. Okay, so here, so structural representation is nothing but a full grammatical and string representation. So now I'll go directly for the example of a string representation. So we can make use of a relational graph, relational matrix, attributed graph, graph isomorphism. These are the various methods of representing your syntactic pattern. Analysis and recognition. So I'll go with the example directly. Okay, string representation. So with examples means it will be easy for you to follow here. Strings. So we can recognize the statement, the sentence in the form of strings. Okay, strings are there are string elements which consist of the characters. It can be of letters or symbols. Okay, so string representation of a pattern is also called as a word. A long string is denoted as a text. Okay. So any continuous string is a part of another string and it is called as a factor. Okay. Now, so we have various recognition with the string. First is we have 4 different string pattern recognition here. First is string matching. Next is string edit distance. String matching with errors. String matching with don't cast symbol. Okay, these are the 4 different string matching. That is a recognition of your pattern with the strings. String matching, string edit distance, string matching with errors, string matching with don't cast symbol. So see one example in each case. Directly we'll go to the example here. See here string matching. See if a text is given and if the string is given, we have to match the string within the given text. Okay. See, can you observe? We have a text like this and the string is given. This is a given string. You have to find out the string. You have to identify the string in the given text. The string is BDAC. Okay. See here. In the given text, you have to identify where you come across this BDAC. So here you come across this BDAC. So you have matched this string in the given text. So this mapping is done after the 5th shift. 1, 2, 3, 4, 5. After 5 shifts, this matching is done here. So S is equal to 5. S is nothing but the number of shifts. So likewise, the string matching will be done here. Next is string edit distance. String edit distances, we are going to convert or transform one word to another word. Okay, transformation of one word, transformation of X to Y. And that is done by means of three different criteria. One is by means of substitution, not criteria, three different methods. One is by means of substitution, insertion, and deletion. Okay, so transforming of one word to another word, that is a string edit distance, and which is done by means of three methods. One is by means of by incorporating the three methods. Okay, substitution, insertion, and deletion. Now coming to this one, see string edit distance. See, suppose my given word is excused. Now I am going to transform this word to X hashtag. Okay, this X to Y, I am going to transform X to Y. That is, excused has to be transformed to X hashtag. Okay, so this is a source string and this X hashtag is a destination word. Okay, first what I have to do is the first two letters and the last two letters remains the same in the case of your excused and X hashtag. See here, the first two letters. Here, see here, first two letters once again. See the first two letters X remains the same, ED remains the same, excused and X hashtag. Now I have to go with the change with this one. So we don't have C in the case of X hashtag. So I'm going to instead of deleting this C, I can make use of substitution. See, as I said here, the previous slide. Substitution, insertion, and deletion. So I am going to adopt these three. Okay, so I am going to substitute. So in the place of your C, I am going to substitute. We don't have C in the case of your X hashtag. So I am going to substitute H in the place of your C. Okay. So I am going to place H in the place. I have replaced C by means of X. Sorry, H by means of C. X hashtag. EXHK. Next, I don't have A here. Okay, so I'm going to insert A. Next is I'm inserted A now. Okay, EXHA, USED. USED will be having. Then once again, I'm going to insert one more letter, which is nothing but T. Okay, EX. I have substituted H in the place of C. This is substitution. I have inserted A. Okay, again I have inserted T before this E. Okay, so that is X hashtag. So I have transformed this excuse to X hashtag, that is X to Y, by one substitution. This is one substitution and two insertions. Okay, transformation of X excuse to Y, X hashtag, through one substitution and two insertions. Is that clear? Next is, this is your string edit distance. Next we move on to string matching with errors. The same, the first one is we saw string matching, that is without errors. We have been provided a string and that matches with the existing text. Here also, the string is provided here. The string is structure. This is a string and we have to identify the structure within the given text. But here we have one error here. So in the case of in your structure, here one error takes place here, I and U. So we can make one substitution here. Okay. Edit distance. Edit distances, we can make one substitution here. In the place of I, you can replace this U. Okay. But the string edit distance of 1. String edit distance of 1 means we have made a substitution of I to U here. And this number of shift is said to be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 here. Number of shifts. It is after this 11th shift, I come across this structure here. Okay. This is string matching with error. So we have one error and that is done by means of string edit distance or mismatch. String edit distance means we have replaced this I by means of U here. Okay, this is a string. I have replaced I by means of U. And I have determined this. I have found out my string. Next is the string matching with don't cast. So hope you might be familiar with the don't cast. So here we have various don't cast. So don't cast can be, there is any character, any letter can be replaced by means of don't cast. See here, actual string is patterns. So which means that here, see in the place of T, we have a don't care, so we can make use of this don't care. We can now substitute. We can assign T to this don't care, which means that PATTER. Again here in this actual string we have a E here. Sorry, in the text we have E. In the actual string we have a don't care, so we can assign E to this don't care. Okay. Now we have these two don't cares here in this particular place. We have both the so both the letters. We don't have any letters, which means that both are don't cares. So we can assign a common letter to this. CPATTERN. So this don't care is equal to N. Okay. So don't care is something we can assign any letter to the don't care. Okay. So this is a string matching with don't cares. So these are the various ways of that is determining the pattern in the case of by using strings, observing a pattern using strings. Similarly, we have grammatical methods. So in grammatical methods, so we have, so once again, Abraham sir.
Yes, ma'am.
Can I continue for another 10 minutes?
Right.
Yeah, ma'am. Up to 12:30 we have time.
Okay. Okay. So next we proceed with the grammatical methods. So in the case of your grammatical methods, here, see here, before going in for this grammatical methods, a grammar can be represented by means of various ways. See here. See, actually, a grammar can be represented by means of 4 tuples or 4 components. One is symbols, variables, and then root symbol and production. Okay, so that is, symbol is nothing but a terminal symbol. So the end of the tree is a terminal symbol. No, and then variables. Variables are nothing but the non-terminal symbols. That is intermediate symbol. Okay, then comes your start symbol or the root symbol, and we make use of the set of production rules. Okay, this is a formal grammar. So I'll show you here. Okay, this is a representation of your grammar. So grammar can be represented by means of 4 tuples. G is equal to Bn, Vt, P and S. So Bn is nothing but your Bn denotes you the non-terminal symbol. So the intermediate symbol. Okay. Vt as a name, from the name, it is a terminal symbol, end symbol. Okay. Next P. P is nothing but a set of production rules. So in order to carry on with this grammatical method, we have a set of production rules. It has to follow the set of production rules. Okay. In order to proceed. S is the root symbol or start symbol. Okay, so this grammar grammar in the case of your syntactic representation will be represented by means of these 4 tuples. Okay, 4 components. Now suppose here, and here we have 4 categories of your grammars. We can call it as a unrestricted grammar, context-free, context-sensitive and context-free grammar, and regular grammar. These are the 4 different categories of grammars. Okay. Now coming to an example. See, this is a normal grammatical representation. See, actually, the terminal symbol is the history book sold over 1,000 copies. So the complete sentence, this is a complete sentence. So we are decomposing the sentence. The history book sold over 1,000 copies is a complete sentence. So we have decomposed the sentence into nouns, verb phrases. Again, that is decomposed. So finally, we'll be getting, these are the end symbols. Terminal symbols. The history book sold over 1,000 copies. That is the end symbol. Okay. Now we move on to an example here. Okay. So this is the example of your pattern primitives. Okay. The subpatterns are called as primitives. See here we have. See, this is a rectangle. So this rectangle can be represented by means of the string form as well as a tree structure. Okay, suppose that these are the primitives which is given here. See this right arrow. 1 unit of right arrow is represented by means of A. 1 unit of down arrow is represented by B. 1 unit of left arrow is represented by C. And 1 unit of up arrow is represented by D. 4 letters. Okay. Now I am going to represent this entire rectangle by means of this pattern primitives. See here, in this rectangle we have 3 units of right. The horizontal line. Okay, the top horizontal line is represented by means of 3 units of up arrow, and the bottom horizontal line by means of 3 units of, this is the right arrow, bottom horizontal line by means of 3 units of left arrow. And we have 2 vertical lines in the case of your rectangle. So the right vertical line represents you the two vertical down arrow lines. Okay, left vertical line is 2 units of up arrows. So which means that, see, this can be represented by 1 unit of right arrow is represented by A. So we have 3 units, A. And down arrow is represented by B. We have 2 units of down arrow, B and B. And left arrow is by means of C. We have 3 units of left arrow, C. And we have 2 units of up arrow, and it is represented by means of B. Okay, so in the string form, the same rectangle can be represented by means of starting from this A, B, C, and B. Okay, this is the tree structure of the same rectangle. See here, A, we have 3 E's, A plus A, plus B plus P, plus C plus C, and then plus D, D plus D. This is head to tail concatenation. Okay, so this plus denotes you the head to tail concatenation. Is it clear? This is a pattern primitive of your rectangle. That is how your pattern is expressed in the form of your string as well as in the form of your tree structure. Now coming to suppose that we want to express this pattern 9. So this is a integer, and I'm going to a number which I'm going to express this number in the structural description. Again, we follow the same rectangular concept. Here we have this 9. We can break this into 2 patterns, 2 sub patterns. Okay, 9 is we have decomposed this into 2 sub patterns. Here we have this rectangular pattern with another sub pattern. Now this rectangular pattern has 2 units. Here this is a small rectangular pattern. We have 2 units of horizontal line and 1 unit of vertical line. Okay, and here this sub pattern. See here, this is a point. This is a junction point of this 9. So I'm starting here. I'm starting from this. So this moves towards the left arrow, which means a C. See here, left arrow is nothing but C here. Left arrow is a C here. So we have 2 C's, 2 units, 2 C's, followed by 1 D. Up arrow is D, 1 D. And then we have 2 units of horizontal line, 2 A, and then 1 B. Okay, down arrow. So this is added with that of another sub pattern. Here we have to start from here. Here we have 2 units of down arrow. So this represents B here. Then again 2 units of left arrow, C. B plus C plus C. So the complete string is C, D, A, B, B, C. This is the complete string of this pattern line. Okay, this is again, we have one more semantic pattern. See, can you observe this image? So this is a scene where we have see here, we have objects as well as a background. We have a background here. So objects placed in this background. So the complete scene we have taken here. Okay, so the scene is decomposed into objects. We have objects and this background of the object. Okay, now coming to in that object, we have 2 objects, object A and object B. Can you observe? So we have object A and object B. Now coming to the background, we have 2 backgrounds. Okay, that is a sub pattern. So one is a floor and another is a wall. See here, floor L is denoted by L. We have a floor L and we have a wall which is denoted by K. Okay, so that ends up with this sub pattern. We don't have any other sub patterns to be decomposed here in this background. So in the background we have a floor L and wall K. That's all. Now coming to these objects. So we have 2 objects, object A and object B. Again further, object A as it is a pyramid which has 2 faces. Object A has a pyramid which has 2 faces. Object that is a face F and face G. Now we have object B which has 3 faces. See here, object B, it has a face H, face I and face G. So we have decomposed the entire scene into, and these are the final terminal symbols. Okay, these are the intermediate symbols or the non-terminal symbols. Okay, so we have arrived the primitives, sub patterns, so called as the primitives. Okay, so these are likewise, we have so many examples in the case of your syntactics, and that will be very interesting topic, syntactic. So I'll give you another example here. So we have different types of string grammars, and then again parsing. Again we have parsing. Again So you see from the bottom to top. So we are decomposing this in grammar is nothing but we are decomposing the sentence into primitives, subpatterns and then primitives. There is a pattern, subpattern, primitive. From the primitive, we will be arriving the statement, that is parsing. The reverse process is called as a parsing. So we have different types of parsing, which is called as a top-down parsing, bottom-up parsing. So this is again another interesting topic where we don't have time to discuss about this topic. And then we have, I think I can rush up with my slides. So this is again, we can describe a pattern by making use of cylinder consists of top and body. We will describe the top by means of its own pattern, body by means of its own pattern, and clubbing these two will be getting the cylinder. And this is again the pattern description for blocks. We have different blocks, and this is a graphical representation of these blocks. A, B, and C, D. We have a block. We have the basement as C. Okay, in stack, they are arranged in the form of stack, and we have the tree representation. Okay, representation of these blocks in the form of tree. Okay, the same pattern description using this is a graphical description here. Now, suppose see here, this will be very interesting here. I'll show you. See, we have a tree-based representation of a cube. We have a cube here. So the primitives of the cube are A, B, and C. This is a final primitives. This will be called as a primitive. So then there is a subpattern called as a primitive. Suppose that C, then here start symbol S. See, considering this as S. So S is decomposed into three subpatterns, A, B, and C. Okay, A, B, and C. So this is the first subpattern. Again, A can be divided into two subpatterns here. So this is a subpattern of A. A can be divided into two subpatterns, B, C. Okay, again A is divided into two subpatterns, B and C. Okay, again B is divided into one more subpattern, C. B is divided into one more subpattern C. Now coming to this B. B is divided into two subpatterns again. Here, A and C. See here, A and C. C and A. Okay, this C is again divided into another subpattern, which is nothing but A. See, C to E. Now coming to this C. C is again divided. This C divided into two subpatterns, B and A. See, C to B and A. Again, A follows again one subpattern B. So this is a representation of your cube by means of your tree structure. Okay, tree grammar. So this will be again one interesting thing. So this is a two-dimensional representation, pixel representation, two-dimensional square array representation. Okay, square array 8x8 binary image, which is represented in the form of quadrant. Can you follow? So here we have the two-dimensional square array of 8x8 binary image in the form of pixel, and that has to be represented in the form of quadrant. See, suppose that here this is an 8x8 binary image. Now we have this image. So let us consider this as a root node. Okay, we are going to divide this into childhoods. So the image has a white background. Background is said to be white with a black foreground. Okay, the shaded part should be black foreground. So when we have a complete black foreground, then the particular node will end up. When we have a complete black or complete white foreground, that node is called as a leaf node, and there won't be any further subpatterns from that particular node. See now this image, this complete 8x8 image is divided into 4 child nodes. See, we have 1, 2, 3, 4 child nodes. See, 1, 2, 3, 4 child nodes. So in this, see, you see the third child node. So third child node, we don't have any combination of your shaded as well as white background images. That is pixels. Shaded and white pixels. We have only white pixels here. Okay. So in that case, this is a leaf node. We have ended up with a third one. Okay, third child node got ended up with a leaf node. Now we have 3 child nodes. See, 1, 2, and 3 child nodes. Okay, once again, we decompose these 3 child nodes into subpatterns. I'm decomposing the first child node into subpatterns. Okay, so in this, again, in this first one, that is, we have subpatterns. We have the combination of both black, that is all shaded and white. And in the second one, it ends up with the leaf node. The third one also ends up with the leaf node. And fourth one also ends up with the leaf node. The fourth one is a complete shaded pixel. Okay, so it also ends up with the leaf node. Whereas the first one is a combination of both the both the shaded as well as the white pattern. So again, this will be decomposed. This will be decomposed into 4 nodes, 4 child nodes. Here, finally, everything will be ended up. Here we have the final white and black background. Okay, likewise, this quadtree will be represented by means of this image will be represented by means of this continues for all the images. Can you follow this? I think I can rush up. So the graphical method we have seen a graph, and then we have one more method called as there is graph isomorphism. So 2 graphs are said to be there is a isomorphic when they have the vertices, when they have equal edges and equal vertices, etc. Okay, I cannot give you the examples because we are running out of time, and here we have an example for graph isomorphism. Next, we go on to an important topic which is the artificial intelligence. So artificial, I'll take for another 5 minutes. I'll give you a brief intro about the artificial intelligence. So artificial intelligence is nothing but the natural intelligence. First of all, natural intelligence. We should know about the natural intelligence. Natural intelligence is the capacity to learn and solve the problems by means of a human brain. The same thing is achieved by means of a machine. So, and that machine will be trained by means of human only. Okay, the intelligence of machines and robots. Okay, with an aim to solve the problems, to act rationally, to act like human is called as artificial. Artificially, we are training the machine to perform the task of a human. Okay, all the tasks that is performed by human will be performed by means of machine. That is called as artificial intelligence. Okay, can AI system work as efficient as human brain? Yes. The answer is yes. See here, so we have 10 power 12 neurons in the human brain, and number of synapses. Synapses is nothing but the communication between the neurons. Okay, junction between the neurons. So we have 10 power 14 neurons. Synapses connecting these neurons. Okay. So the decision will be taken by means of the human brain will be at a cycle time of 10 power minus 3 seconds, 1 millisecond. Okay, so for a computer, so it has a more number of transistors per CPU. So even in the case of when we go in for a supercomputer, hundreds and thousands of transistors or CPUs will be having in the case of your supercomputer, and the cycle time. See here, the cycle time will be of the order of 10 power minus 9 seconds. Okay, for a computer. So which means the conclusion is yes, your machine can act as a human brain. Okay, but the difference, what is the difference between your AI and human? The difference is that here creativity will be there in the case of our natural intelligence. Okay, see, but here everything is programmed. There won't be any creativity in the case of your artificial. So, and the results will be precise. The results will be precise because everything is programmed, and based on the program, it will give you the accurate result, precise result. But here we'll be predicting. So, one time we'll be predicting this, and the next time we'll be predicting that if you want to identify a human, first time we'll recognize him and the person as he belonged to this class. Again, oh no, that person, that student belonged to the other class. Likewise, our prediction will not be precise. Okay, precise by your natural intelligence will not be precise. Consistent. So, that is by repeated measurements, the output is going to be consistent in the case of your artificial intelligence. It will not be consistent by means of natural. Okay, and then multitasking ability. So, this machines can perform multitasking, but that will not be done by means of human. So these are the main difference between your AI and your human here. And then so history of AI, I'll skip on this slide. History of AI, the fields. So we don't have any field now. As of now, we don't have any field without this AI. So all the fields are associated with this AI. These are the fields where AI is associated. Okay. And now fields of AI, mainly in the case of your robotics, aviation and automation, then computer science, telecommunication, okay, daily life applications, day-to-day applications, home security, bank, digital cameras. So these are some of the applications. And we have two types of AI, which is your hard AI and soft AI. Hard AI is hard AI is AI, which is associated with the missions and infrastructure, whereas soft AI is the algorithms and your software. That is related with that of your algorithms and software. And whenever we have advantages in the system, we do have disadvantages. So limited ability is limited. Real-time response will be slow in the case of your AI. Coding is difficult. Cost, as you know that it is high. There is implementing AI-related missions is to be highly costlier. See, when we talk about phone, when we have a normal phone without a smartphone, smartphones are said to be costlier than that of your basic mobiles, ordinary mobiles. Okay, so this is one example I am giving you, and it cannot handle emergency situation, because it cannot act accordingly. That is only it will be programmed for a certain situation. So if the situation varies, it cannot handle the emergency situation. So I think I have done to some extent I have done my part. These are the future works of your AI. As of now, we know that we can recognize a face, but the videos cannot be recognized. So video-based face recognition is one of the research areas in the case of your artificial intelligence. So I think with this I can complete my presentation. Sir Abraham, sir?
Yeah, ma'am. Thank you, ma'am, for giving
my presentation, sir.
Yeah, it was very wonderful, ma'am. Thank you. Thank you, ma'am, for your giving your valuable insights regarding this topic on pattern recognition and artificial intelligence. You also demonstrated how how it works in real life. Also, it was very wonderful, ma'am. Now we'll go ahead and take some time for questions.
Okay.
Any questions, you can just unmute and ask. Ma'am, yes, sir. Mini project ideas, Dinesh sir is asking. What are
mini
the
project ideas?
Yeah.
Oh, okay, sir. That is mini project ideas. I will send you, sir. Because
Yeah, ma'am.
I have to think about it.
Yeah. Thank you,
Definitely,
ma'am.
I'll send you the mini project ideas regarding this in this field, sir.
Yeah. But it was very informative session, madam. Very insightful. You have covered fundamentals, complete fundamentals. Really, it was a fantastic session. Student, it's prepared according to the student understanding level only. So really a nice session, madam. I think students were not having much question. So mini project idea you can share later, madam, so that I will share with student, so that those who want to explore, they will definitely work on that line.
Okay, sir. Thank you very much, sir. Thank you so much. Thank you very much, sir, for providing me this opportunity and for coordinating. Abraham, sir.
Welcome,
sir, for coordinating.
Yes, madam.
I would like to thank once again your principal, Dr. Mohan Kumar, sir, Dr. Dinesha, sir, for giving me this fantastic opportunity, sir. Thank you so much.
Yeah, welcome, madam. Welcome. Over to coordinator.
Thank you. Yeah. Thank you, sir. Dinesh, sir, for your valuable input. Now I would like to call upon Mr. Rajesh for giving a vote of thanks.
Okay, sir.
Thank you, sir. Thank you, Abraham, sir. Yeah. Very
I'll just
wonderful
stop my
session, madam.
presentation.
Yes.
I'll stop my presentation, sir, once again.
Okay, ma'am.
Okay, sir.
Yes. Very thank you, madam, for wonderful session. What you given to our students and then scholars and whoever it may be attended in this session. Thank you, everyone. And it was a pleasure being with you all today through this online platform. And I would like to thank everyone who made this meeting possible. And special thanks to our Dr. P. Mangayarkarasi Madam and our Principal Dr. Jitendra Sir Mungara and our Dean Dr. Mohan Kumar Sir and then Dr. Dinesh Kumar Sir, Dr. Dinesh Sir, HOD of CSC Department. Thank you each and everyone, sir. Thank you, madam. Very warmful greetings to you, madam, for attending and taking this session. Very grateful, and then it is very helpful for all the students who are attended here and scholars also. Thank you, madam. Thank you very much.
Thank you, Rajesh Kumar, sir. Thank you so much. Abraham, sir, shall I leave the meet?
Thank you, ma'am. Yes, I request all students to stay back. We need to take a pledge of this. We'll stop the recording.
Yeah. Well.
Thank you, sir.
Yeah. I think we need to switch on the camera, right, for a pledge.
Sir,
yes, sir. Yes, sir. Yes, sir. Have to switch on camera, sir. All students.
Yeah.
Yes,
so
sir.
Students, whoever can do switch on, please can switch on the camera.
Okay, sir. Okay, sir.
So you have to record it and take snaps also.
Yes, sir.
Sir.
Yes, sir.